Well, hello again everybody. Well, it's a Saturday today, it's a day off, so I'm not at work, so I'm quite happy and far less grouchy than I have been all week. So what I thought we would do today is we're going to use my programming tool, my Mini Pro TL866, and what we're going to try and do is we're going to download the code off this memory device here. I don't know what type of memory device it is. It says that it's a 27C512 ROM, and I would have said it was probably an EEPROM chip at one point because it's got a label on it, but maybe that's just a label. So I don't know what sort of chip this is. Yeah, I'm going to use this Mini Pro TL866, and these are available really quite cheaply from lots of eBay sellers on lots of eBay sellers. I think they come from China or somewhere like that. And if I can actually get it out of the box, I think you've seen this before. They come with a variety of programming headers and things like that to fit, PLCC packages and stuff like that. And they are relatively low cost. I can't remember what they actually are. I think they're like, I don't know, maybe £50. I mean, the programmer I use at work costs like several £100s. It's made by a company called Dataman. But this one is, very cheap, but made by Mini Pro. And yeah, it's always done everything I've wanted to do. It's not failed me yet. So yeah, I recommend it. Right, okay, I think I'm going to have to tell it what type of chip it is. So it's a 27C512. So I've got to remember where you select the chip. I think you do that here. So 27C512. And it's bringing this up. I can see a listing here for an AM 27C512 DIP 28 package. And yeah, I think that's probably what it is. So we'll select that. So if you just click on the information tab here, it brings up a little picture of the programmer, and that's showing us which way we need to insert the chip. So I'm putting the chip in and just making sure I've got pin 1 towards the little programming lever that it shows here. Plug the programmer back in, and right, and now I just want to make sure that I find the right button, because I don't want to program it, I want to read it. So how do we read? Read from the chip. So I guess it's as simple as that. So hopefully you can see what I'm doing. So in theory, all I have to do now is just press this read button here. Well, that didn't work. Let's see if I can find out what's gone wrong. Well, I wasn't sure why that didn't program, so basically I just took the label off the top of the chip to get the full part number and the manufacturer, which is an Atmel chip. So basically it says that, oh, I'm going to have to get my magnifier glass out. So it says that on here, I'm sure you won't be able to see it, but it says that it's an AT27C512R. So yeah, again, now I know it's an Atmel chip. What I did was I went onto the programmer and I searched for Atmel devices, and I think I found the right one now. I just double checked the information, and yeah, it goes in the socket just the same way as the other one. So I guess what I need to do is have another go at reading it. So let's see if we do any better this time. Here we go, read, and let's try the read button. Oh, it didn't like that either. And again, it looks like probably because I selected the wrong one. I'm not having a good day today. What am I doing? Why am I being such an idiot? So I'm looking for, let's go to Atmel devices. Right, so we want Atmel. And we want a, what did I say? AT27C5. See, that's a different package, isn't it? 28. Is it that one? AT27C512R. Yeah, I think I'll have to reshoot this video again, because there's no way that I'm going to put online what an idiot I am. I can't even use an EEPROM programmer. So we'll just forget this never happened. You will never see any of this. I don't want to disillusion you, because I know you all think I'm some kind of electronics god. Yeah. Right, does it still fit in the same socket? Yeah, that looks right. Come on. If this doesn't work, I really am going to give up. So let's try read again. Read. There we go. Third time lucky. Okay. So it's read that, and just so I don't accidentally reprogram it or do anything I shouldn't, I'm just going to take the IC out of the programmer now. Just unplug the programmer. Right, and I'm just wondering if we had any, if there was any comments left in here. So here's the chap that originally, I think, invented this this board and wrote well, I don't know if he wrote the basic compiler or he converted it to run on this Z80, because basically this runs basic. And yeah, the name of the chap is Grant Searle, and I can see his name there. So it just says by Z80 by Grant Searle, cold or warm restart. I'm not exactly sure what any of that really means. I'm kind of wondering, is it like the origin address for where any of this starts? Basic version 4.7, copyright to 1978 by Microsoft. So I don't know if he's actually put in a lot of the instructions here to tell you how to work the thing. Or maybe some of this is the text that gets printed up on the screen when the equipment starts up. I'm not exactly sure, you know. But what we've proven is we can read the we can obviously read this ROM, and what I can do is I think I can save this as well. I'm just having a look through the contents of the ROM, because I was just interested to see how it marks, or if it does mark any unused sections in the ROM. You know, if they're filled in any particular way. So it looks like the program goes up to about, you know, the entire program for this he only uses a small section of it, goes up to 1 dBO. And is there anything after that? No. So the majority of this EEPROM is actually totally empty. So we're finished with the programmer, so we can put that away. And as I said earlier, this TL866 Universal Programmer, well, it doesn't just program, as we saw, it can read from EEPROMs and memory devices as well. And I spend, you know, like all people on YouTube, all the electrical people, we all spend a lot of time slagging off stuff from China and saying how cheap and badly made it is and all the rest of it. And the reality is, this Mini Pro works for me faultlessly. It's never failed me. It wasn't expensive. To actually buy something comparable by one of the big name, you know, EEPROM programming people would probably cost you £700. And yeah, it's a good one. So well done, China. Thanks for that. Can you imagine there's probably millions of people at this very moment all over China with a huge sigh of relief to get an endorsement from AllTheGearNoIdea. Yeah. So thumbs up out there, guys. Keep going. We'll get there in the end. I think I was telling you all a story the other week and about when I worked at Tandy, and as usual I didn't get to the point. I don't think I got to the point anyway. I'm just waxing on lyrically or not. Does anybody know if you can still buy those tools for inserting ICs? Or has anybody got any good ones or any they'd recommend? Because well, you know, you can always use more tools. You've never got enough gadgets, have you? But that was what I think when I started talking about Tandy, that's what I was going to come on to. I remember buying this little, I don't know, it was like a syringe thing, and it had like folded metal ends on it, which would basically, you'd insert the IC into the end of this like pump assembly, and it would just basically bend the legs to the right angle to fit into the socket. So you would basically feed the IC into this insertion tool, and you'd hold the insertion tool over the socket, press like a plunger down, and it would push the IC in. And yeah, that used to work really well, because I have noticed that, you know, you buy ICs and they're in a socket, and again, I always thought that that socket was maybe designed to you know, again, to slightly pre-bend the legs so that when you push down into the socket, it would insert the IC into the socket correctly. But, you know, I've got loads of sockets up here that have, you know, have come with picks and other things, and they don't seem to line the pins up correctly at all. So, yeah, I just wondered, has anybody got any tips and tricks for inserting ICs into sockets? You know, I'm quite prepared to believe I've been getting it wrong for all these years. Maybe there's a better way of doing it. If there is, let me know. Oh, right, we haven't built up the serial board yet, have we? So let's just bang that up. For some reason, I thought we'd built this serial board the other day. Must have got distracted. I don't think this this extraction fan I've got on, it's not really doing a great deal, but well, at least it's keeping the smoke out of my face. It's you know, helping it dissipate a bit. It's actually quite strange because I've got the fan set to blow at the moment, and it's blowing towards me, but the actual smoke is going in the opposite direction to the draft from the fan, so I don't quite understand that. Right, is that okay? Yeah, that will do. There's a couple, now this board that I'm building up, it's actually the serial UART board, and oh, that socket doesn't fit there. And there's a couple of options for building this. You can either use an FTDI cable, which is, I'm sure you know, converts USB into serial, or you can use a MAX 232. And I think I said in one of the other videos I quite wanted to use the MAX 232 chip because, well, let's face it, that's just a little bit more old school, isn't it? It's a little bit more interesting. And I would like to do that. But it doesn't come with a MAX 232, and I don't actually think I've got one. So we'll go ahead and maybe just populate it to use the FTDI. And when we get a MAX 232 chip in the future, we'll put one in. I just noticed that I need a socket to fit that MAX 232. We'll see if I can find one in a minute. Might as well put it in if we can find one. I'm probably telling you for the third time, I am quite a believer of putting things in sockets because yeah, well, because it's easy to make a mistake and blow something up, and you don't want to be soldering ICs in and out. You're wondering why my soldering's so bad again today. Well, two reasons. One, I'm probably rubbish at soldering anyway, but two, just so you can see what I'm doing, I'm actually leaning around the tripod, because I've got the tripod at the side of me, so I've got this board. I haven't got the board in front of me, I've kind of got it to one side, which just makes it that little bit more awkward. You've got to have all these excuses ready, haven't you? Does that get Joe's seal of approval? Come on, Joe, leave us a comment. Okay, I think that's probably not too bad. Now the final thing to do with this serial board is to insert this 63B50. And basically what that is, it's a serial UART device, and probably just to explain it in its simplest form, it takes in parallel data from the microprocessor and transmits it serially, or it takes in serial data and puts it in a parallel format onto the data bus so the microprocessor can pick it up. So basically it's serial to parallel, parallel to serial, kind of probably you might call it a shift register. It does a little bit more than that in that it does some of the handshaking and the framing of the data, and you know, works out the correct clocking frequency and all that. So there is more to it than just a shift register, but that's really the easiest way to think about it. Now I'm not sure if this is one of the chips, this 63B50. I don't know if it was one of the chips that was actually specifically designed to work with the Z80 processor, because when they brought the Z80 processor out, they didn't just bring out the processor, they did also bring out a range of peripherals to go with it, and the whole idea was just to make it as easy as possible for designers to get little microcontrollers up and running. So yeah, that's what they did. I'm not saying that that did come out at the same time, but I think it's quite possible that it did. Anyway, well, all I've got to do is stick in this UART chip, and yeah, we're done as far as this board's concerned. I was just about to put it in the wrong way around then, so yeah, let's put it in the right way. Again, trying to bend in these legs. You know, the bigger the chip, the harder it is to actually get it into the socket, because you know, you can, if you hold your finger in the right place and you know your tongue at the right angle, if it's a small chip, you can just you know, you can hold the legs in as you press it in, but as the chips get a bit bigger, you know, it gets older, it gets harder to press them in. And I can see some of these legs, particularly that one, I can see that one's trying to fold under in the wrong place, and that one there's trying to fold to one side. Yeah, really not doing very well at putting these in. Okay, that one went in. Sorry, I think all that might have been off camera. Yeah, I was saying that I always seem to struggle putting ICs in sockets. Maybe it's something you get better at with practice. It's not something I've had a lot of practice at in recent years, and yeah, I seem to have been struggling with these. But I do think part of it is because of the sockets that you get with this. The sockets are just made out of bent strips of metal, and they don't really guide the pins into the sockets very well. I mean, I've got to admit, sometimes the turn pin headers are even harder to get the legs of an IC into. They can be even much less forgiving. But yeah, these sockets aren't particularly good. Right, so that's completed now. Really, we could do with, if we were going to use a MAX232, we'd have to put some capacitors in here as well, which are used by the chip as a charge pump device. But I think we're going to have a first go at this using the FTDI interface, just to see if we can get it up and running. So yeah, until we get the MAX232 chip, that's all we can do with that, I think. So I think, seeing as we're still in the construction phase, we might as well, just to finish off, we should just build up the I/O board. And basically the I/O board allows us to, you know, it allows the microprocessor, the microcomputer, to interact with the real world. So from what I can tell, it's got a number of LEDs, which I'm assuming is the output port, and we've got a number of push buttons that we can use here to generate inputs. So we might as well just build this up, and then yeah, I think that'll be a good little test. Maybe we can write a bit of a test program to run on this little microcomputer, and you know, we'll have to do the old Knight Rider thing and see if we can get the LEDs to scroll across from one side to the other, you know, all that kind of thing. You've got to do that, it's like the law, isn't it? Right, so it looks like this is the digital I/O board that we've got to build up. So I don't think I'm going to bother reading the instructions. All I want to do is basically see what it looks like on this picture, because that will tell us everything we need to know. Now, I honestly didn't look at this earlier. I've just noticed that they give you a little bit of example code you can type in here, and what they've described it as the simple Cylon scanner. Now, you know, I think I was talking about the Knight Rider, you know, where you get the red LED and it goes from one side to the other. Well, I don't know if anybody remembers Battlestar Galactica. In the original series, you had these Cylon Cylon robots, and they were kind of like chrome toasters, weren't they, that used to walk around being unpleasant. And what the guy who's designed this, he's written the simple Cylon scanner program here in BASIC, because I've said to you, if you have you know, if you have LEDs on a computer and you're writing software, it is just the law. Like, you have to do it. The first thing you have to do with anything that has LEDs on it, you just have to program it to have the LED to, you know, to trace from one side to the other. Now, of course, I am talking about the you know, the original series of Battlestar Galactica, not the new series that had that. Oh yeah, it had that. Is it an Australian woman? I don't know, I've forgotten what her name is, but you know, the Cylons in that, some of them are quite tasty. In fact, one of them has this blonde hair and has this really quite pretty red dress on. Yeah. Be right back. Right, okay. Carry on. Well, so far I haven't actually really had an in-depth look at the circuit diagram for any of this actually, but particularly not the I/O board. But you know, when I did have a quick look, it looks as though effectively the I/O is memory mapped. It looks like a portion of memory to the Z80 that you can either write or read from. But one of the interesting things about the Z80 is that it has this I/O line, which I believe it raises when you're actually addressing any external I/O as opposed to RAM or ROM. Because again, just going off what one of the guys said to at work was talking to me about this, and he'd done Z80 programming in the past, and he pointed out that he thought that there was some unique instructions on the Z80 that were to do with I/O as opposed to just general writing or reading to memory. So yeah, I don't really know anything about that in detail, but certainly if you look at the Z80 pinout, there is I don't know if it's called something like IQ request or something like that, but yeah, there is a dedicated chip enable which is used to well, I guess to enable the I/O board and separate it from being just a general read-write to memory. Okay, so I don't think it really matters what order we build this in. I'm kind of thinking that probably some of the smaller components, I can see this some 6x1N4001. These are little diodes, aren't they? Little signal level diodes. So I think it might be a good idea, just because they're jammed up against the header, it might be a good idea to yeah, just to put them in first. So we'll do that. And I can also see a couple of links that need to be installed. It certainly says link here, so we might as well put them in at the same time. It does show some links on here, so we'll just solder them links in. I think it said when I started reading some of the instructions for this that you know, you could build one of these kits in about 2 hours. Well, I've got to admit, anybody who could build one of these kits in 2 hours is well, all I can say is you're doing well. I couldn't build one of these in 2 hours for sure. I mean, I'm quite prepared to believe that you know, I'm not the fastest worker in the world, but I'm not the slowest either. Maybe it's like anything else. If you've had a lot of practice, you know, you can. Right, we've got some 330 ohm resistors on that side, and we've got some 2K2s on that side. I'm guessing the 330s, they're going to be, you know, that's a typical value for a dropper resistor for an LED, isn't it? Whenever I'm taking the resistors off, you know, a bandolier or a reel like one of these, I like to cut them off, because what you'll find is if you just pull them off the tape, this tape that they're attached to, sorry, there, you can see they're on tape. If you pull them off there, you'll find that there's a little bit of sticky gum attached to the leg, and when you actually put that resistor leg through your board, some of that goo will wipe off. It'll wipe off inside the hole, and potentially it can make a bad connection, makes it harder to solder. So just a little tip there: it's better to cut them off than it is to pull them off the reels and then you know, and then thread it through. You get a better job. I think it seems to help if you fold the legs in very tight to the body of the resistor. I think if I was doing this, making this kit, I probably wouldn't have gone for discrete resistors. I would have used one of those single inline packs, a sill pack, a sill resistor pack. I think that would have been a bit easier and quicker to install, but I suspect you know, the resistors are a lot cheaper. Well, they're a lot cheaper if you take out the you know, the cost of the manual handling, which is obviously no cost if it's a kit, but it would probably be a reasonable saving to do in a production environment, to replace these with sill packs. These are going a little bit easier now. I've you know, bent the legs tight against the body. I should have probably done it that way with the others. I think I might just put these push buttons in next. You remember all the trouble I had with the other push button, the reset button. Yeah, I don't know how well the camera's going to focus on this, but I hope you can see the legs are just slightly splayed out on either side of the push button. It's not a big problem, but it's not quite right. Right, LED time, with the short leg being negative. Now, the annoying thing about LEDs is when you put them all in a board, especially a row like this, if they're all at different heights, again, that always annoys me. So I'm going to solder them right in so they go flat bottom against the board, which isn't necessarily a good idea because it puts a lot of heat into them when you solder them, but yeah, that's what I'm doing. Oh no, we lost an LED. Maybe we've lost two LEDs. That was bound to happen, wasn't it? Oh, there we go. Right, we just need a few ICs now, and we are finished with the I/O board. And I'm guessing that these are very similar to what the purpose of the other ICs with the memory. It's just going to be some form of maybe address decoding or latching. So we need what's that? A 74138, which is that one. So we'll have you, and you go that way around. Yep, that's correct. 74. Next one. What are the next two? 74245. Don't know what that is. 74245, but there it is. And this is a longer one, which means it'll be more awkward to get in. And this, in theory, should just leave us with one left, which should be a 74374. 74374. So all good. And that one went in without too much of a fight. Well, I suppose what you want to do now is see me plug it in and test it. But I think for today, that'll do. Bye bye for now. See you again soon. Teaser. Ow, one of those bloody IC sockets has just bitten me. Bloody thing.